Hello and welcome to SigmaXL video tutorials. In this video, I'll be demonstrating the Two Sample Mann-Whitney and Two Sample Kolmogorov-Smirnov and exact tests in SigmaXL. The Two Sample Mann-Whitney test is the non-parametric equivalent to the parametric Two Sample t-test. The test is null hypothesis median difference equals 0, and alternative hypothesis median difference does not equal 0. The test does not assume sample normality, but does assume that the samples have equal shapes. If the shapes are different, the null hypothesis is that the distributions are the same. The optional two-sample KS or Kolmogorov-Smirnov test is used to compare the distributions of two samples. The test is null hypothesis, distribution CDF difference is equal to 0. Alternative hypothesis, distribution CDF difference is not equal to 0. The CDF is the cumulative distribution function. The two-sided test statistic is the maximum absolute difference between the CDF values as shown. We will use the familiar customer data dataset and compare medians of customer satisfaction by customer type. Click SigmaXL, Statistical Tools, Non-Parametric Tests, Two Sample Mann-Whitney. Check Use Entire Data Table and click Next. Stack column format is selected by default. Select Overall Satisfaction and click Numeric Data Variable Y. Select Customer Type and click Group Category X. Set the alternative hypothesis to not equal to. Check Display Two Sample KS. Click OK. Select Customer Type 2 and 3. Click OK. Given the p-value of 0.0008, we reject the null hypothesis and conclude that the median customer satisfaction is significantly different between customer types 2 and 3, with customer type 2 having the higher median satisfaction score. This confirms previous findings and matches the result of the two-sample t-test for means, which was demonstrated in another video. We also have an output for the two-sample KS test. Given the p-value of 0.0035, we reject the null hypothesis and conclude that the satisfaction distributions are significantly different between customer types 2 and 3. This also agrees with the results from the Mann-Whitney test. Now I'll redo the previous example to compute the exact p-values. Typically this would not be necessary unless the sample sizes were smaller, each sample n less than or equal to 10 for Mann-Whitney, but this gives us continuity on the example. Due to the large number of permutations, we will use Monte Carlo exact for this analysis, and will consider a small sample problem later. Click the Sheet 1 tab. Click Statistical Tools, Non-Parametric Tests Exact, Two Sample Mann-Whitney Exact. With stack column format checked, select Overall Satisfaction and click Numeric Data Variable Y. Select Customer Type and click Group Category X. Ensure the alternative hypothesis is set to not equal to. Select Monte Carlo Exact with the default number of replications equals 10,000 and confidence level for p-value equals 99%. Check Display Two Sample KS Exact. Click OK. Select Customer Type 2 and 3 and click OK. Given the Monte Carlo p-value of 0.0006, we reject the null hypothesis and conclude that the median customer satisfaction is significantly different between customer types 2 and 3. The Monte Carlo p-value is very close to the previous example's large sample result. This was expected because the sample size is reasonable, each sample n greater than 10, so the large sample p-values are valid using a normal approximation for the Mann-Whitney statistic. The Monte Carlo p-value, 99% confidence interval, is 0 to 0.0012. Note that the Monte Carlo p-value will be slightly different every time it's run. The output for the two-sample KS Monte Carlo test is displayed. Given the Monte Carlo p-value of 0.0019 with 99% confidence interval 0.0008 to 0.003, we reject the null hypothesis and conclude that satisfaction distributions are significantly different between customer types 2 and 3. As with the Mann-Whitney, the Monte Carlo p-value is very close to the previous large sample result. Let's consider a small sample problem. Click SigmaXL, Help, Sample Data, and then double-click the file stimulanttest.xlsx. Researchers conducted an experiment to compare the effects of two stimulants. 13 randomly selected subjects received the first stimulant, and 6 randomly selected subjects received the second stimulant. The reaction times are in minutes. We'll test the null hypothesis of no difference between the medians of the two stimulants against the alternative that stimulant 1 has smaller median reaction time than stimulant 2. Click SigmaXL, Statistical Tools, Non-Parametric Tests, Exact, Two Sample Mann-Whitney, Exact. With stack column format selected, select Reaction Time and click Numeric Data Variable Y. Select Stimulant and click Group Category X. Set the alternative hypothesis to less than. Select Exact with the default time limit for exact computation equal to 60 seconds. Note that the two-sample KS exact option is only available for Monte Carlo, so it is grayed out. Click OK and select stimulants 1 and 2. This sets the order for the one-sided tests, so the alternative hypothesis is median 1 less than median 2. Clicking OK will provide us with the results. With the exact p-value equal to 0.0527, we fail to reject a null hypothesis, so cannot conclude that there is a difference in median reaction times. By way of comparison, we'll now rerun the analysis using the large sample Mann-Whitney test. Select the Reaction Time tab. Click Statistical Tools, Non-Parametric Tests, Two Sample Mann-Whitney. With stack column format checked, select Reaction Time and click Numeric Data Variable Y. Select Stimulant and click Group Category X. Ensure the alternative hypothesis is set to less than and click OK. Select Stimulant 1 and 2 and click OK for the results. Now, with the p-value equal to 0.0421, we incorrectly reject the null hypothesis. The difference between exact and large sample p-value is small, but it was enough to lead us to falsely conclude that stimulant 1 resulted in a reduced median reaction time. In conclusion, whenever you have a small sample size and are performing a non-parametric test, always use the exact option. This concludes the two-sample Mann-Whitney KS and exact tests tutorial video. For more videos, visit www.sigmaxl.com or join us on YouTube. Thank you for watching.